Okay, hi everyone. Today we're going to do Cambridge IGCSE Additional Mathematics 0606 May June 2025 Paper 1 Variant 2. So this is a Paper 1 non-calculated paper. So this is one of the first few years that they implement the new syllabus with the no calculator for Paper 1 and also the circle equation for the coordinate geometry part. Right, so that's the two main things they have implemented in this new syllabus. And today we're going to be doing the May June paper 1 2 lah. And I've this copy of the paper gotten unofficially, so that means we do not have the maxim out yet. So basically I'm doing this blind. I've not seen any of the question. I also don't know what the answers gonna be like. So uh feel free to pause and try to do it yourself before you look at the video for the solution. Right, so let's try and do it now. So I'm not going to use the calculator to do also. So if you see any arithmetic mistake made in the video, please let me know. Okay, so paper one, polynomial question. We want to find the equation of this cubic polynomial. So right, first thing you notice is a modulus. I mean fx will be two possible, will be plus minus, right? Because there is a modulus in there. Right, and then we also have the roots, right? So this one will be x equals to negative 2, x equals to negative 0.5, and x equals to be 3. So from this we can get all our three um, factors, the linear factors of our polynomial. So we can just put it as fx will be equals to plus minus a of the first one, x equals to negative 2, so it's x plus 2, x equals to negative 0.5, so it's 2x plus 1, and x equals negative 3, that is x minus 3. Right, so that's for the first part. Now we want to find this constant a. Okay, so to find the constant a, we need a known point on the graph. Right, so it's like this one. We know this point, it will be the y-intercept, and also the x coordinate will be 0 and the y coordinate will be 2. So I can write it like this: f0 will be 2, then I can equate it to the unknown function that we have. So a here, you get, right, so our final function will be plus minus 1 over 3, x plus 2, 2x plus 1, x minus 3. Okay, next. Question 2. So it looks like a quadratic equation in disguise. I'm going to rewrite this equation. So I'm going to multiply both sides by this x 1 over 3. And instead of adding together the exponents, I'm going to write it more like this, so you can see clearly that it is indeed quadratic in terms of x power 1 over 3. And I believe this should be factorable since it's a no calculator paper. Right, so our solutions will be these two. And thus x will be negative 27 and 8. Right, so two real solutions for our equation here. Next, given a circle equation and show that this line is tangent to the circle. Okay, so what we need to do is to sub this y into this equation here, and for tangent, right, for tangent, let me just write this down. Recall that the discriminant will be equals to 0, such that the quadratic equation will only have one unique solution, one real solution, right? So let's try and substitute this in. Right, so after I've simplified it further, I'm left with this quadratic equation so that I can finally use this discriminant. So b squared minus 4ac will be that in this equal to 0, therefore it is a tangent. Okay, given that this tangent touches the circle at point P, find the coordinates of point P. So to find this coordinate, we just need to solve this equation for the x coordinate. right? So we write the equation first. So if you can recognize this, this actually in the form where we can do this, and there is a repeated root here, so our x with only one solution, which is 3. And now to find the y coordinate, we just need to substitute into this this straight line equation. So our p coordinate will be 3, 3. Right? Okay, next, for find the equation of the circle which has the center at P and passes through the origin. So let me just sketch out what this looks like. So it's useful to sketch out some information when there is a lot of things given to you to help you picture it easier. So the origin is here and the center of a circle is here. So maybe I would draw the circle like this. So it's not really an accurate drawing, but it's just a sketch. So at least we know what we're dealing with. So the circle passed through here, and the center is here. So maybe I can write out the circle equation, so it's easier to reference here. So two important things for a circle equation we need to know is the center AB, as well as the radius, right? So the center at P, we already know that, just we need to find the radius. So the radius is quite easy to find, we're just using the Pythagoras theorem. So 3 squared plus 3 squared. So I will just leave it as a cert 18 for now, because once we substitute into the circle equation, we'll have to square it anyway. So remember, for if the center is 3, 3, we need to make it the negative version when we substitute the value into the circle equation. So it's minus 3 and minus 3 and 18, right? Question 4. Find the integral from 0 to pi of sine theta d theta. Right, first of all, let me just copy the integral. Right, we know that the integral of sine theta, you get a negative cosine theta. And we need to substitute the limits of the integration into this one. So we'll get a negative cosine pi minus a negative cosine 0. So no calculator paper, we need to try and recall what the values of these are. And remember, for anything involving calculus, the angle involving trigonometry and calculus, they will always be in radian. Okay, so let me sketch out what the cosine graph look like. So this will be 2 pi and this will be pi. So at theta equals to 0, right? Theta equals to 0, this will be 1. So this one will be a negative 1. Okay, and then cosine of pi is here, so it will be at a negative 1. So minus negative 1 minus negative 1, there will be a positive 2. Alright? Given that alpha is within these two angles, show that this expression can be written as sine alpha. Okay, so we have a few reciprocal identities here. So secant, look at the third letter, so that's 1 over cosine. Cotangent, the third letter is t, so that will be 1 over tangent. So let me just rewrite this in and I'll rewrite both the tangent in sine over cosine form. So now we're got here, I want to combine this this in the denominator into one fraction. So maybe I can do the cross multiplication. So I still have this 1 over cosine at the top. And so this top bottom cosine, it cancels off actually. And the cosine squared and the sine squared is actually equal to 1. Right, so maybe I can highlight here, this is equal to 1. So it can be simplified. So this 1 over sine theta, sine alpha. So this will be the reciprocal of the reciprocal, So that would just be left with sine alpha. Right, so that's proven. The polynomial p is such that, well, this expression where a and b are integers, it's given that the derivative of p evaluated at -1 is 21, and that x minus 2 is a factor of px. So we want to find the values of a and b. So perhaps I can just do this one first. So remember, if something is a factor, once we evaluate at that point, it will be equals to 0. So p evaluated at 2, it will be 0, and we just need to substitute the values in, right? So okay, so we will just leave this as one equation first, and now we deal with the derivative. And since we know that the derivative evaluated at -1 is 21, we can substitute the values in, where a should be able to get as -2, and once you substitute the value into here, you should be able to get b is 8. Hence, write px as a product of linear factors with integer coefficients. So right, so let's just rewrite the equation. So to factorize this, I'm going to use the long division method. You may use any method that you like. And we know that x minus 2 is a factor already, so I'm going to use that as a starting point. Okay, so after we fully factorize this, we can able to write it as a product of x minus 2 and 3x squared minus x minus 4. And this quadratic factor we can factorize even more. Okay, so 3x and x. So yeah, this will be all the full factor of px, the linear factor. Right, finally solve this equation using your values of a and b. So first I'm going to write this out. Right, and then if you notice that this e power 6 y, you can rewrite it as e power 2y cube, and this e power 4y, you can rewrite it as e power 2y squared. Okay, so now we have a polynomial in terms of e to the power of 2y. So similarly, we can do the factorization, except we replace the x with the e to the power of 2y. So, okay, so we have 3 linear factors equals to 0, so each of these will yield a solution. And okay, so since we know that the exponential term cannot be negative, right? So e power something must always be positive. So this will be rejected. Okay, so there's no real solution for this. And what we need to do is we can just take the natural log on both sides. So we get this one. Right, so since this is a no calculator paper, you're not expected to give any numerical value for this type of non-exact answers. You can leave them in its exact form. Alright, so you can just leave it in its natural log form. Alright, next. When the natural log of y is plotted against x cubed, a straight line passing through these 2 points are obtained. So find y in terms of x. We know that this is true. It's a linear form, and we know we can find the gradient using these 2 points here. So our gradient will be, right, our gradient will be -2, and we can use one of these points to get the y-intercept, right? So we can substitute. Maybe I choose the 0.25, right, and then, right, remember we don't have to, we don't have to cube it again, because this is already our these points will be these points will be represented as these points already, so we do not have to go and put it in the ln, or we don't have to cube it again. So our y-intercept will be 9. Okay, so first of all, I'm going to write everything back into its form. And to get rid of the natural log, I'm going to raise both sides by uh, e to the power of. So on the left hand side I get 1, I mean just y, and then on the right hand side I'll get negative e to the power negative 2x cubed plus 9. Right, so we have found y in terms of x. Now we want to find the value of x when y is 25. Y is e to the power of 25. Right, so we just have to equate e power of 25 to e to the power of this. So since it's raised to the power of e on both sides, I can just get rid of it, and x will be negative 2. Right? Okay, a geometric progression has a fourth term of this and a sixth term of this, where k is constant. So let me just write it down. And the common ratio r greater than 0 is positive. So find the common ratio in terms of k and the value of the first term. Right, so we know that the term-to-term rule of a geometric series will be this one. Right, where a is the first term, n is the nth term, and r is the ratio. So we can use these two terms. U4 will be also AR power 3 and U6 will be AR power 5. So if we take U6 over U4, that will give us R squared. Okay, and we can also do this with the other, with the value, the expressions that are being given. So we can try to do some mental arithmetic here. So 32 over 8, that's right. So our R square will be this one. Then once when we take the square root, there'll be a plus minus, but since we already know that R is positive, we can just ignore the negative square root. So our R will be 2 over 3k squared. Okay, so that's the first thing that we have found here. Now we also want to find the first term, so do not forget that. So probably we want to just substitute into U4. So if we use U4, okay, so if we use these two values, we can actually see that A will be equals to 1. So our two final answers here will be R and also A, right? Okay, given that this geometric progression has a sum to infinity of 3, find the possible values of k. So the sum to infinity, if you forget the formula, like I have, the formula is on the first page. This one. Sum to infinity is a over 1 minus r. Right, so as infinity is 3, which also a over 1 minus r. And we must remember the condition that the modulus of r is less than 1. So once we take this into account, so let's try and solve for this one. So a we know is 1, so I'm going to just rewrite it. Right, so once you solve this equation, you should be able to get k is plus minus 1. So that's the two values or possible values of k. But let's also check whether if this validates or is validated by this condition or not. So we know that r must be in between -1 and 1. So let's put our expression for r in there. So indeed that will be true because our k, once you square it, there will be less than 1.5 or in between lah. So this one will be true and is validated. Okay, and it's given, okay, question 8, it's given expression of y and we want to find the derivative evaluated when x is 0, giving in the form of the natural log of p. So let's try and do this. for dy dx, we have to use the quotient rule here, or if you rather do the product rule as you express the bottom as the exponent of -1 is also fine. So we leave the bottom first, differentiate the top, subtract the derivative of the bottom, which is 1, and the top, and divide it by the bottom squared. And okay, we don't want to, I'm not going to simplify this, so because we want to find, we want to evaluate it when x is 0, so we can just directly substitute the x value in. Right, so I'm just left with -1/4 ln 16. So this -1/4, I can bring it to the exponent of the inside of the natural log, 16 to the power of -1/4. That will give me, right, ln 1/2. Okay. And given that x increases from 0 to h, so that's our delta x, and h is small. Since h is small, we can approximate the change with this expression, and we want to find the approximate change in y. So we know that the delta y will be the derivative multiplied by the change in x. So we know the change in x is just h, so we just have to write h multiplied by ln half. Okay. Okay, next, question 9 is about functions. So given that this function exists for x greater than a and f inverse exists, find the least possible values of a. So we know that for a natural log graph, the argument inside must be greater than 0, not inclusive, because we know that a natural log of the negative number does not exist and the natural log of 0 does not exist. So whatever that's inside the natural log, in this case 3x minus 4, must be greater than 0. So x will be greater than 4/3. So that's the least possible value of a will be 4/3. And that's our final answer. And for your range, or for value of a, find the range of f. So actually for the range of, for this value of a, it does not really restrict the range of f, because it's still, for a natural log graph, if you can recall, it looks something like this, where this will be the asymptote, or our a value in this case is 4/3. So even if you restrict it here, the y value, it will still be all real numbers. So right, the range of fx exists within all real numbers. And for your value of a, find the expression of the inverse f. So first, we're going to swap the variables. Right, we swap the variables and we want to find back the original y variable. So right, so remember when we do the inverse, remember to give your final answer in terms of f inverse. So we cannot just leave it as y equals to the expression. We must put it in this form, where we have showing the f inverse explicitly equals to this function. Okay, and it's given that the equation f equals to f inverse have two real roots, means they intersect twice. And for your value of a, sketch the graph of the function and the inverse function, label with the intercepts and the asymptotes. Okay, so first I'm going to sketch the natural log graph. So since that is the inverse, that's the original function. So I'm going to first, use a ruler for this in your real paper, but first I'm going to draw generally the shape. So for natural log graph, it looks something like that. Maybe I'll draw it a bit steeper. Right, so I'm going to label this as y equals to fx. And we know that the asymptote, right, so the asymptote will be, again, use a Use a ruler for your exams. So draw a dotted line to represent the asymptote at 4/3. And now I'm going to draw the symmetry line. So again, use a ruler. And we're supposed to draw this one. So we know that the asymptote will be at 4/3 also. So I'm going to sketch it like that first. I'm going to generally sketch it. Okay, so I can label this as y is the inverse f. Okay, and then I'm going to label the asymptotes. Here is also, okay, maybe a bit too messy here. This line will be x equals to 4/3. This line will be y equals to 4/3. And then this black color line, that will be y equals to x, the symmetry line, which the inverse will be, they will be reflected against. And this line, I'm just going to extend it a bit so that it shows that they intersect at 2 points, right? Because they are two real roots. Okay, so they must intersect twice, and the shape of the graph must be correct. Okay, what else I'm missing here is about the intercepts, right? So we know that for this inverse, for the y-intercept, we just have to evaluate x at 0. So here will be 5/3, and here it will also be 5/3. Okay, so this is what it will look like. Question 10 is about circular measure. So there's a lot of information here. Alright, I'm going to slowly read it first. So we want to find the shaded region, the area of the shaded region, in terms of r and theta. So this one was also r, and if I'm reading correctly, this OD, it will be 4r/3. Okay, so the strategy will probably to take this entire sector OCD, right? OCD, take away the triangle OBE. Right, so that will be our strategy here. So the area shaded, this sector area can be represented by 102 r squared. So the r will be 4/r squared times the angle in radians. So just leave it as theta. Here also, this triangle area, we can use the formula of half r squared sine theta. Right, so that's the triangle formula, and yeah, we can just leave it like this since finding in terms of r and theta. So maybe if you like, you can just simplify a bit. 8/3 r squared theta minus half r squared sine theta. Okay, sorry, 8/9. Okay, for the next part, we want to find the perimeter of this shaded region. Okay, also in terms of r and theta. So, okay, obviously, okay, so maybe we can label this as alpha and alpha, and we know that all these three angles add up to become all these three angles add up to become 180 degrees or pi radians. So alpha will be pi minus theta over 2. And we want to find, right, the perimeter, so we also need this arc length. Right, the arc length of AB is equal to the arc length of EF, so it's r theta and r alpha, where alpha will be pi. Yep. So we just leave this like this for now, and we'll deal with this one. We need to find BE. Maybe we can use a bit of trigonometry. We can split this into half, and here is theta over 2, and here will be BE over 2. Right, so this will be the opposite, and the hypotenuse will be r. So we know that sine theta will be BE over 2 over r, and BE therefore we can get by having 2r sine theta. Right, and then now to find the perimeter, you just have to add up all the values. 2r, 2r sine theta, 2r pi, this one. So these two cancel, and we are left with, right, this will be the final answer. I believe for BE you should be able to use the cosine rule to find also. So that's also should be fine. Okay. Okay, question 11 is vectors. So OA is A, OB is OB here is B. Point P, okay, lies that OP is 3/4 of OA and AQ is 1/3 of AB. So first we want to find OR in terms of AB and mu. So mu, we need to include PR and PQ in the calculation. Okay, so maybe write OR, what paths we can possibly take. So O to R, and we need to involve PQ. So we want to go from O to P, then P to R, right? So O to P and P to R. And we know PR we can rewrite it as mu multiplied by PQ, but OP, right? OP we can also represent it as 3/4 of OA. So 3/4 of OA adding together with mu multiplied by PQ. Right, so I think OA we have it, but how do we find PQ? Right, so for PQ we can represent it as P to A and then A to Q. Right, so maybe I can write it at the side here. PQ, P to A to Q. Right, so there's a bit like slightly more tricky thing that we need to do. Right, we know that OP is 3/4 of OA. So P to A, that will be 1/4 of OA. And then AQ, we can represent it as 1/3 of AB. And AB, it will be negative A add with B. So PQ, now we know how to find in terms of A and B. Right, now we can replace this into our equation here. Now I believe I made a mistake here in my PA. So PA is actually 1/4. So from O to P, that is 3/4. So here is 3 and here is 1. So this should be actually 1/4 and 1/4. Right, so after simplification, you should be able to get this expression, okay, for OR. So this will be our final expression for OR. And hence find the values of lambda and mu. Right, so we are given in the question also that OR is lambda of B. So we can equate this one that we found and also the one that given in the question. So right, so this will be what we equate, and since there's no a here, so it's actually zero, adding with 0a. So in the a unit vector direction, we can actually equate this to 0, right? So mu will be 9. B, in our b unit vector, we have 1 over 3 mu is lambda. So lambda will be 3. Right, last question 12. A curve is such that its gradient is given by this function. So this actually, they are straight away giving us the derivative of the curve, and the curve passes through this point. So we want to find the stationary point on the curve. So perhaps we can first find the x-coordinate of the stationary point. If we recall that the stationary point, the derivative will be equal to 0. So therefore, this one will be 0 and x will be 2 over 5. Right, so now we have the x-coordinate. We want to find the original function y so that we can find the y-coordinate also. So to find the original function y, we just need to integrate this function. To do that, we will add 1 to the power. So the power becomes 4 over 3 and divide by the power and divide by the derivative of the inside function. Then add 1 to the power again. Then we remember this is an indefinite integral, so we have to add a plus c behind. And we can simplify this even further. Right, so this is our y. But to find the plus c, we should make use of this point. Right, so at this point, this is true. So c will turn out to be just 4. Right, and then your y should turn out to be this function. Now we can find the y coordinate by substituting our x coordinate inside. So at x is 2 over 5, y will be, so that's it. So the stationary point will just be 2 over 5 and 4. Right, so this is the last question. So good luck on your exam and thank you.